The relationship between AI development and supply chain attacks is really twofold. On one hand, developers now are using AI to build faster, deliver more packages, and even test using AI as well, which is massively increasing the attack vector. And on the other hand, you've got bad actors who are now using it to find more vulnerabilities, create more malicious packages, and even in some cases, automate social engineering, right? It's quite serious. I can say at Cloudsmith, we use AI heavily to develop. We are releasing cutting edge features using AI faster than we ever have done. But the problem now is that the amount of supply chain incidents we're seeing in the market because of this is far beyond the scale that any normal security team can handle manually. They just can't possibly keep up with it. And so this is where things like, artifact management policy engines come in, because they are an automated response to what is essentially now an automated problem. We cannot manually get ourselves out of this. We have to automate to fix it.
So the difference between a vulnerability scanner and a dependency firewall is a vulnerability scanner can be run just about anywhere. You can run on the edge, you can run in your CLI, and this will tell you if there are known flaws or vulnerabilities in your software dependencies. With a dependency firewall, it's solving a few problems. First one is, rather than pulling blindly from those open source upstream registries, instead you're pulling or proxying through this dependency firewall. And at this point, we can enforce certain controls to say what we don't do and don't permit as far as software dependencies. Likewise, we can augment the information from things like the vulnerability scanner. So we also get to tell if it has a vulnerability, a flaw, but we can go further again and check for things that don't show up in the vulnerability scanner, such as, is it a malicious package or not? The idea here is we're doing these controls via dependency firewall at the earliest possible stage. So developers don't accidentally or deliberately pull in malicious code into their environment only to scan it later via scanners. The CRA requirements are really changing the relationship between organizations, the software vendors, and the actual end consumers in a few ways. In the past, we fundamentally trusted software vendors. That's why we buy software from them, and we trust that it's safe and secure. What the CRA is doing is it's basically setting a set of instructions on what is now mandatory that all software vendors should be doing, whether that be auditing all the software dependencies, confirming, if there's exploitable vulnerabilities in the code, but also just general best practices are enforced as now recommended controls within CRA. So as a consumer, you now have the trust that all software vendors now legally have to comply with CRA, and therefore you understand that software should be safer moving forward.